The goal of this tutorial video is to introduce you to drawing brain lesions and overlaying and viewing those lesions. By the end of it, you should know how to draw a quality first draft of a brain lesion. In subsequent video tutorials, I'll go over more advanced techniques for drawing brain lesions, but this one is just an introduction. I'm going to be using MRIcron, so hopefully you've downloaded that. See the link in the description if you have not. And I'm also going to be using the MRIcron Workshop Materials folder. See the link in the description to get that. First, I want you to go into the MRIcron Workshop Materials folder. And we're going to be working with materials in this Brain Lesions folder. First, I'm going to open the MRIcron. To do that, just go into MRIcron, select the icon. So once you have MRIcron open, I want you to open the brain that has the lesion in it that we're going to be working with. So go to File, Open, and navigate to the Brain Lesions folder within the MRIcron Workshops Material folder that you've downloaded. And we're going to work with Patient 1 JGL. So select that file, click Open, and now you'll see this brain file open. And when I'm working with a damaged brain, the first thing I do is go and survey the brain slice by slice. And so I'm going to go up here by the S. I'm going to left click and hold and scroll down and get a sense for where the lesion is. And so clearly you see that there's something going on right here on the left side. So you see that there's damage here. And it's noticeable because you see in the right hemisphere it's intact. And generally speaking, using the intact hemisphere as a guide for what should be there is a way to tell where the brain lesion actually is. So holding my left click and scrolling up, you can see here the lateral ventricles. And so we can determine that this here is not clearly lesion because you can see in the intact right hemisphere that there is also this space here. And so there is some enlargement in the left hemisphere, and this becomes an issue in how you define what is lesion and what is, in this case, an enlarged ventricle. But at minimum, you should be able to tell that there is some of this is actually normal and not due to the lesion. So when you're starting out drawing brain lesions, the easiest heuristic to use to determine if the tissue is lesion or not is to look at the intact hemisphere. So it's not critical for our purposes to define the lesion such that it's a complete mirror image of the intact hemisphere, but it is a good guide for defining what is lesion and what is not. And so in the Z slice 22, I wouldn't define all of this or any of this portion as lesion per se. This is within the normal range of ventricular size. As I'm scrolling more inferiorly here, this is an enlarged ventricle, but it's continuous with the lesion, so I would include some of this posterior portion of the left lateral ventricle as part of the lesion. Before we go any further, I want you to open the lesion drawing guide that comes with the MRIcron Workshop Materials. So go into the Brain Lesions folder and select the Lesion Drawing Guide. And what we're going to do is go through this guide in sequence, and you can work through it in more detail on your own. We're going to cover the key concepts for when drawing the lesion. Okay, so the tool that we're going to use to draw the lesion is the bubble tool. If you don't see these options up here on the right side, go to Draw, Show Drawing Tools, and you should see them. And we'll be using this 3D bubble tool. the first thing you do to use the 3D bubble tool is go to the coordinate of interest. Okay, so go first to where you want to draw the bubble. And in the instructions, I've provided good starting places, coordinates, and parameters for you to work with. As you learn how to use MRIcron, you hopefully will get better at identifying good starting places and parameters yourself. Here, these are predetermined by me to facilitate instruction. So go to this coordinate, -51, 1, -31, and to do that, go to View, M&I Coordinates, and again, -51, 1, -31. I've determined that to be a good starting place. To draw the bubble, all you need to do is select, left-click on the 3D bubble tool. And now you see, the beginnings of a lesion already drawn. But you might notice that this drawing, the red portion here, extends outside of the brain. You can see a little red here, and includes things that we don't want to at this point. The reason, though, that this tool is so useful is because it draws in 3 dimensions. And so it allows you don't have to draw slice by slice or line by line. You can draw in 3 dimensions simultaneously, and this greatly speeds up the lesion drawing process. So the next thing we want to do is change these parameters here, this difference from origin, difference at edge, radius, and this erode parameter. So I'm going to move this down here, and in the guide we have these different parameters that I have predetermined as being useful for drawing the lesion here. So I'm going to input 44, 21, and 13. And I'm going to increase the erode to 2, and that just trims down whatever bubble we've drawn. Okay, so if you've gotten this far, you have a great start to your lesion. Before we go any further, let me go over what these parameters mean in a little bit more detail. And you can go to your lesion drawing guide and scroll all the way down to the appendix to get more detailed descriptions. The origin is the original coordinate that we went to, the -51, 1, and -31 coordinate that we went to. That's our origin. And the critical aspect of the origin is the intensity value. In this case, it's 36. So the other parameters are with reference to the intensity value of this voxel. So the difference from origin is 44 intensity values relative to the origin. So 44 relative to 36. So what this means is that any voxel with an intensity value of 36 plus 44, or 80, is going to be included in the bubble that we've drawn. And the difference from the edge is also with respect to intensity values, but instead of the origin, it's with respect to the edge of the bubble. To get a better intuition of what this means, in the appendix, in this example, you can imagine in 2 dimensions, right? We're drawing a 2-dimensional bubble, essentially a circle, where we're at the 0 voxel, and we're drawing a bubble that expands throughout the entire grid here, but it's constrained by a difference from origin of 10 and a difference at edge of 4. So anything less than 10 is going to be included. So we have all these 9s here, these 6, and this 3. These 3s are included. You'll notice that these 9s over here are not included. That's because the bubble relies on these 2 parameters. So the difference from edge has to be 4. So the difference between 3 and 9 is 6, and that's greater than 4, so it's not included. And of course the 13s aren't included because 13 is greater than 10, which is the difference from origin. So all of these 9s are included because the difference is less than 10, and the difference from the adjacent voxels is less than 4. So you might wonder about between this 3 and 9 is the difference is 6, but the difference between the 9 and the adjacent 9s is 0. And up here you have the difference between 6 and 9 is 3, so that's less than 4. So this is going to be included in this bubble definition. So I've included this example and these descriptions here for you to work on in your own time, gaining a better understanding of what these parameters are. I will say that it's not critical for drawing brain lesions to really understand deeply what these parameters are. For the most part, I advise you to set good starting parameters for, say, the difference from the origin or difference at the edge when drawing a lesion, and stick with them throughout drawing the lesion for a particular brain. And these are parameters that I have, again, had predetermined are useful for drawing a lesion in this brain. And this is actually a critical part of speeding up drawing lesions, so you don't dwell on changing these parameters too much. The important parameter that you will change is the radius of the bubbles. So another exercise that might help in developing your understanding of these parameters is, if I change the difference from origin to the maximum, so 255, and change the difference from edge to 255, then really I'm just drawing a sphere, okay? And I could increase the radius of this sphere or decrease the radius. And so this is, if you don't have any of these difference parameters set, then really you're just drawing a sphere. And so we can go back to the parameters that we had, so the 44 and the 21, okay? And after you draw this bubble, you click apply to have it set. So now you've started the lesion. So now that we've started our lesion, all you really need to do to draw the rest of your lesion is to select somewhere else in what you visually determine to be lesion. So right here, this seems to be lesion right here. And you see that in the comparable region in the intact hemisphere, that you see that there is tissue there. So this would be lesion. And so we can then select the bubble tool again, right? And you see that it fills in the lesion. And now, given the radius that I've included, it's continuous with the previous bubble that I drew. And so now we can increase the radius if we want to make this bubble a little larger, a little bit more inclusive. And I like that, and so I'll click apply. And so now we've built upon our previous bubble. And really what you're going to do is just add bubble after bubble. So I'll click up here and select another bubble. So notice that I'm not really changing the difference parameters. I'm really changing the radius parameters, right? I can, and you can change the erode parameter to make it more or less inclusive. I tend to keep it, whatever I start out with, I tend to keep that throughout. And so I can click apply. So the other thing to keep in mind with adding these bubbles is that in order for these difference parameters to be useful, you want to be approximately close to the intensity value that you started with. So the original intensity value was 36, and so now the intensity value of this voxel is 41. Okay, so that's relatively close to the starting intensity value. And that is why these parameters tend to work. And so that's a very useful heuristic for drawing these bubbles. So another thing you can keep in mind when adding bubbles to your lesion is that when you go to a particular voxel and use that as your origin, and then say you want to click somewhere else, you change that, whatever you had set before as the origin is the origin of that bubble, okay? And if you wanted to now change the origin to this voxel, right, where we've clicked right here, you can set reset origin. And it won't stay until you click apply. And so you can click around and change the origin, reset the origin to whatever you want until you focused on a voxel that you think is good. So this one it looks good, and I might increase the radius here, and then I'll click apply. Okay, and let's say I want to start adding in a portion of the lesion here, and now we're getting into the territory where it's not clear if it's lesion or it's ventricle, right? And so this is where a lot of the variability in drawing lesions comes. Okay, so we can click Apply, and let's say we want to remove a portion of this lesion. So clearly this portion, it looks like it's ventricle on the intact hemisphere, and so maybe we should have a portion of this not filled in to kind of outline where the ventricle would be. So you can click on this portion, and what we can do is select the bubble tool again, and instead of having it set to append to current VOI, we can delete from current VOI. And what this is going to do is delete out a sphere from wherever we selected. And we can change the radius of that deletion here, so I'm just decreasing it. And you'll see that this deletion is now decreasing. So let's say we think that looks reasonable. We can click Apply. And I'm not going and cleanly drawing the lesion right now. This is just for demonstration. I will say that generally having an outline that reflects a mirror image of the intact hemisphere is a good way to when you're starting out to draw lesions. Okay, I will come up with more advanced tutorials in the future, but for this one I'm just giving you the very basics for drawing a good starting draft of your lesion. Okay, so another tool that is useful for drawing is the zoom tool. So we can go to this drop-down menu here where it says Fit, and we'll drop down. Let's zoom down 4 times. And now we're getting a lot closer. And so when we click on the bubble tool, let's say we want to delete this portion, then here we can do it in a more precise, detailed manner. And click Apply. So now we can zoom back to the default so it fits the GUI. And another tool that might be useful while you're working on it is the symbol here, which temporarily removes the lesion. And so as I select this wizard's hat symbol up here, whatever I've drawn temporarily goes away, and I can more easily determine whether this is too inclusive or not inclusive enough. Okay, the last thing I want to point out about drawing lesions are these other tools. So here you can see this pen tool up in the upper right. And so if you select this tool, you can draw, right? But it only draws in 2 dimensions, so I tend not to use it. And so you can go through these and try out these other tools. But for the most part, using them to draw lesions is very time consuming, and I would not recommend them. I would recommend getting used to using the 3D bubble tool and only using it. Otherwise, it can get much more time consuming. And this is a good opportunity to show you the undo option. So you can do Control-Z to undo one back. So you can't undo multiple edits to your lesion. You can only undo one. So keep that in mind. It might be a good practice to save often, actually, given that you can only undo one change back. So if you do select one of these options, you would have to deselect it, so when going back to just the normal way to interface with MRIcron. Okay, so keep that in mind. And when you have a lesion that you like, the way to save is to go to Draw, Save VOI, and VOI means volume of interest. And when you do that, you will go, in this case it's going to the Brain Lesions folder and the workshop materials. And you can change the name to, in this case, let's change it to JGL Lesion. And we can change the format as well. I tend to save everything in Nifty format, but you can change it in this VOI format as well. But keep in mind the VOI format is a format specific to MRIcron. The Nifty format is a general format that can be used with many different brain imaging softwares. And so if you select that, you'll see the other Nifty file format files. Click Save, and now you've saved it. When saving, it's very important to keep in mind to use the Draw Save VOI option. Do not use the File Save as Nifty option. The mistake that I've seen happen is when people have drawn lesions and then gone to File, Save as Nifty, and then name this as their lesion, right? And so what they do is save the underlying brain as their lesion, and they lose the information that they've worked with. So keep that in mind. You can either save the underlying file if you make edits to it, but we're not going over that today. or you can save the lesion itself. So keep that in mind. You can also open a lesion. So let me close the lesion I've drawn and go to Draw, Open VOI. And we want to change the format. Remember, we saved it as Nifty format. And so you'll go to this drop-down menu in the lower right and select Neuroimaging. And you select the JGL lesion that we just drew. Okay, so up to this point, we provide a basic introduction to drawing lesions using MRIcron. And now we can go back to our guide and we can get into a little bit more detail. So if you scroll down on page 2, there is a JGL drawing guide. And if you follow along this guide step by step, you'll be able to draw the quality lesion for JGL. Okay, so these are the coordinates and parameters that I've used to draw JGL's lesion. And so we've already started with this first coordinate and then use these specific parameters. So if you go then to this coordinate, the -56, -59, -21, and input a radius of 9, you'll then add another bubble and keep adding these bubbles. Eventually you'll get to a final lesion that I think is of reasonable quality for at least a good first draft of JGL's lesion. So another important exercise is for you to compare the lesion you've drawn to that of the lesion that I've included in these materials. Let's say what we have here is a lesion that you've drawn. What you can do is overlay the lesion that I've drawn, and so you can go to Overlay, Add, and you can go in the workshop materials, Brain Lesion folder, in the Lesions folder, you can see lesions that I've already drawn. This is the Lesion 1 JGL. And again, if you follow the JGL drawing guide, you'll be able to create this lesion on your own, step by step. And so we can open that. And what this does is provide an overlay on top of the lesion that we've already drawn. And it might make it easier to view this overlay. If you go to this drop-down window, you can see here the background is the underlying brain, and you can see this is the overlay that we just added. Okay, and we can change the color to make it maybe a little clearer. Let's change it to green. Okay, and let's change the intensity value, minimum and maximum, to 1 and 1. And it's still not super clear. The last thing we need to do is overlay transparency on other overlays. We want to make it additive. And so now anywhere is yellow is where the lesion you drew now overlaps with the lesion that I've included in the materials. Anywhere is red is from the lesion you drew, and anywhere is green is unique to the lesion that I've included. So this is a way for you to compare what you've drawn to what I've included. And this is a good exercise for you to compare and contrast the quality of what you've drawn to what I've drawn as a good lesion. And so as you're starting out, you'd want to see more yellow. So the more overlap, the better you're doing at drawing these lesions. So the next thing we want to do is go over drawing the other lesions that I've included in these materials. And so here in Part 4, you can draw your own lesion for these other files. And so if we go into the Brain Lesions folder, you'll see that there are other brains with lesions. And here is our good starting parameters for these specific files that I have gone in and determined are good starting parameters. And so what you'll do is say for patient 2 DPT, I'm going to select that and open this file. What you'll do is go to this coordinate, the -40, -32, -22, and you'll set these parameters in the bubble tool. And then you'll go and just proceed by adding bubbles, keeping these parameters the same except for the radius. Okay? I've included these good starting parameters for each of these different brains, so you can go and draw them on your own. And then in the lesions folder, you'll see that I've already included the pre-drawn lesions, that you can compare what you've drawn to the already included lesions. One thing you can do that might be useful for giving a summary update to somebody that you're working with or an instructor for a class, save a snapshot of this window and send it to somebody. You can go to an informative voxel that shows a good view of what you've done, and then go to File, Save as Bitmap, and this just saves this screen. And so you can save it as GL lesion snapshot, and it saves a bitmap image. Okay, so another thing you might be curious about is the volume of your lesion. And so let's go to Overlay and Close Overlay, and we can go to Draw, and we can go to Descriptive, and that gives us some information about what we've drawn. Here it gives in the number of voxels, okay, right here, and the volume in cubic centimeters here. So 42.72 cubic centimeters. That's the volume of the lesion that I've quickly drawn here. So in the next tutorial video, I will go over the next portion of this lesion drawing guide and go over how to combine lesions together and to view them as combinations of lesions.